Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2195 indicates that the air-fuel AF sensor signal is stuck in lean mode. This means that the engine's computer, known as the Engine Control Module, ECM, is detecting a higher than normal air-to-fuel ratio during operation. The AF sensor, Sensor 1, is pivotal in maintaining the ideal air-fuel mixture for optimal combustion efficiency and emissions control. Typically located in the exhaust system, just before the catalytic converter, it plays a crucial role in measuring the amount of unburned oxygen in the exhaust gases. When this sensor signal is dysfunctional, the engine may display performance issues and increased emissions, leading to potential failure during emissions testing. Proper troubleshooting is essential to address this issue effectively. DTC P2195 concerns the AF sensor, Sensor 1, which is integral to fuel management and emissions control. The primary function of this sensor is to measure the air-fuel ratio by detecting the level of oxygen in the exhaust gases. Positioned before the catalytic converter in the exhaust system, its accurate readings help the ECM adjust the fuel injection accordingly. If the readings indicate a lean condition consistently, it suggests that either there is too much air or not enough fuel entering the combustion chamber. This issue can lead to poor engine performance, stalling, or other drivability issues. Addressing this DTC begins with systematic troubleshooting to identify the underlying cause. Several factors can contribute to the P2195 code appearance in the Honda Civic. One possibility is that the mass airflow MAF sensor or intake air temperature IAT sensor is contaminated with dirt or debris. These sensors are crucial for determining the right amount of air entering the engine. Additionally, a loose or disconnected AF sensor will directly influence the air-fuel ratio readings sent to the ECM, potentially throwing off the balance and triggering this DTC. Another potential culprit could be a malfunctioning engine control module, ECM, or powertrain control module, PCM. If the computer is not processing information accurately, it can lead to erroneous readings and diagnostics. Identifying these causes systematically is vital to ensure effective repairs. When facing DTC P2195, several symptoms may manifest. Drivers may experience poor engine performance, reflected in sluggish acceleration or misfiring, especially under load. Decreased fuel efficiency is also common. A lean condition typically means the engine is compensating by using more fuel to maintain performance. The check engine light will illuminate on the dashboard, signaling a need for further diagnosis. In some cases, excessive emissions can lead to failing emissions tests, which is especially critical for compliance with environmental regulations. Recognizing these symptoms early facilitates prompt attention to the issue, often preventing more significant problems down the road. The initial step in troubleshooting DTC P2195 involves inspecting the MAF and IAT sensors for any dirt or debris. These sensors should be clean to ensure accurate readings of both air mass and temperature, which directly affect fuel delivery. If dirt is found, it should be removed using appropriate cleaning solutions designed for electronic components, ensuring no residue is left behind. If cleaning does not resolve the issue, consider replacing the MAF or IAT sensor, as failure can lead to continuous recirculation of inaccurate data to the ECM. After addressing these components, it's crucial to proceed with further diagnostics to determine if the P2195 code persists. Step 2 involves a thorough inspection of the AF sensor installation. It's essential to check whether the sensor is securely attached to the exhaust system, as any looseness could cause erratic readings impacting engine performance. Additionally, you should verify the electrical connections for any signs of disconnection or wear. damaged wiring can result in an inconsistent signal. If any issues are found, corrections must be made immediately, whether that entails securing the sensor more firmly or replacing any affected wiring. A well-connected AF sensor is crucial for maintaining proper air-to-fuel ratio and ensures the ECM functions correctly. In this step, you will need to turn the ignition switch to the on position without starting the engine. This indicates that the vehicle's systems are powered and prepared for diagnostic checks. The Honda Diagnostic System, HDS, will be used here for accurate communication between the vehicle's onboard computer and the technician's diagnostic equipment. Clearing the DTC with the HDS is essential to reset the system before proceeding with further diagnostic tests. This action refreshes all codes and allows for a clean slate to assess whether the P2195 returns once the engine is started and idling. Establishing a baseline is crucial for effective troubleshooting. After clearing the DTC, you should start the engine and allow it to idle for at least 2 minutes. This period allows the engine management system to stabilize and ensures that any faults in the AF signal can re-emerge, if they exist. During this time, monitor the engine's behavior closely. Any irregular sounds, vibrations, or struggles in idling may point toward ongoing issues. Post-idle, check with HDS for any pending or confirmed DTCs. If DTC P2195 reappears, it reinforces the likelihood of a persistent issue, which will require further exploration as outlined in subsequent steps. In this step, utilize the HDS again to check for any pending or confirmed DTCs. Pay special attention to whether DTC P2195 is indicated on the screen. If it appears, it indicates an ongoing problem that must be addressed. The next step will require examining the connections at both the AF sensor and the ECM or PCM to ensure there are no poor connections or loose terminals. This can be pivotal in resolving the communication flow between the sensors and the ECU. Should the HDS reveal no presence of P2195, it indicates an intermittent issue, which may also warrant further inspection to identify any underlying causes that might not have triggered immediate codes. For this troubleshooting step, turn the ignition switch to the lock 0 position. This ensures that all electrical systems are powered down before making adjustments. Carefully reinstall the AF sensor, ensuring that it is seated tightly and securely connected to its harness. This step is crucial in preventing future connection issues. After reinstallation, turn the ignition back to on 2 and prepare for the subsequent steps, which involve resetting the ECM or PCM. Proper installation of the AF sensor not only helps resolve DTC P2195, but also assures the integrity of the entire exhaust measurement system. With the AF sensor securely in place, the next task is to switch the ignition back to on once again. This step prepares the vehicle for resetting the ECM or PCM using the HDS. Resetting these modules is pivotal since it allows the engine management system to establish new operational parameters following any repairs or adjustments made to the AF sensor. A reset can clear out old, potentially problematic data and serve as a fresh start for the system. Once the reset is completed, the vehicle will be ready for further diagnosis to confirm whether the earlier fault persists or if the system now operates normally. After resetting the ECM-PCM, it is essential to carry out the ECM-PCM idle learn procedure. This procedure helps the control unit to adapt and recognize the new engine conditions as well as operating parameters. A properly functioning idle learn ensures that the engine maintains correct RPMs at idle, reducing the likelihood of further issues. Understanding how the engine responds to changes is crucial for long-term performance. Once this procedure is completed, Monitor the system for the emergence of DTC P2195 again. This helps confirm if any adjustments made have effectively resolved the underlying issue. This step involves monitoring the onboard diagnostic (OBD) status using the HDS. It is crucial to determine whether DTC P2195 indicates passed or failed. If the screen reads passed, this signifies a successful resolution of the previous issues and confirms that the system is functioning correctly. However, if it shows failed, check for any poor connections or loose terminals again at the AF sensor and the ECM/PCM. The failure may suggest that the wiring may still be problematic, warranting a closer inspection. Should the result be not completed, it is advisable to continue idling until the diagnostics yield a result. If the P2195 code remains unresolved, the next step involves checking if the ECM or PCM has the latest software updates. Outdated software can lead to erroneous readings and codes, affecting the overall performance of the vehicle. If updates are available, install them to ensure optimal system function. If the software is up to date but the code persists, substitution with a known good ECM or PCM may be necessary. This step is important to rule out any hardware issues with the vehicle's main computer. After updating or substituting the unit, continue testing to verify if DTC P2195 is still present and assess the new performance of the engine management system. To conclude the troubleshooting process for DTC P2195, it is essential to ensure that the code has been effectively cleared from the system. This verification is performed using the HDS, confirming that the issue has been resolved. After clearing the fault codes, conduct a test drive to understand how the vehicle performs under various driving conditions. During this drive, keep a close eye on engine behavior, fuel economy, and the check engine light. Any reemergence of the P2195 code needs immediate attention. Conducting this thorough verification is crucial, ensuring that the issue was accurately diagnosed and repaired, allowing for peace of mind in the vehicle's ongoing performance. Preventive maintenance can significantly reduce the occurrence of DTC P2195 and associated issues. Regularly cleaning the MAF and IAT sensors helps maintain their accuracy, ensuring they correctly measure airflow and temperature. It's also wise to monitor the quality of fuel being used. Low-quality fuel may contain contaminants that can affect sensor performance and combustion efficiency. Additionally, conducting routine diagnostics on the vehicle allows for early detection of potential issues, whether electronic or mechanical. By focusing on these preventive measures, the overall health of the vehicle can be preserved, leading to better reliability and performance over time. In summary, diagnosing and addressing DTC P2195 is a crucial process for maintaining the performance of your Honda Civic. Identifying symptoms early, from poor engine performance to illuminating check engine lights, can lead to timely interventions. Following the systematic troubleshooting steps ensures that every potential issue, from sensor cleanliness to connection integrity, is thoroughly investigated. Remember to prioritize regular maintenance practices, such as sensor cleaning and diagnostics, to prevent such codes from appearing in the first place. In doing so, you will not only enhance your vehicle's performance, but also extend its lifespan, giving you a reliable ride for years to come. Please like and subscribe to the channel. See you next time.